So you should all have a handout for exercise 202, which is what we're going to work through today. If you were in my 135, which a lot of you were, this should look very, very similar to what we did in the AutoCAD part. Okay? And in fact, it's almost identical. But it's also kind of, we're stepping back in the world of Rhino. We're not doing anything 3D today. It's all going to be 2D. Should be really easy for those of you that have worked in AutoCAD, those of you that had 135 before. It's still important to understand how Rhino's set up. So we're going to take it slow and simple in the beginning and build upon everything that we learn. I think one of the important things about Rhino is while it may seem simple in the very beginning and you may pick up on it really fast, everything snowballs. So you learn a certain set of commands today. Next class you come in and I assume you understand and know all these commands, and then we move on to the next set. And so each day we'll be building upon what we learned in the last set. We do have a solution, thanks to Kristen, for the people that didn't have V-Ray load correctly and it wasn't there. So now I know how to fix that problem. So we will fix that for those of you that need it, and we'll move forward from that. OK, so first thing is when we first open up our Rhino file here, you may get a splash screen. I've already gone past the splash screen in my case. I should have waited. If you're picking a template, the large object inches template is the one you want to pick. And we want to make sure when we're modeling in Rhino that our default units are in fact in inches. If you're more comfortable in a unit other than inches, let's say you want to work in the metric system, I don't have a problem with you working in that, though all the stuff that I'll give you will be assuming you're working in inches. If you set your units to feet, when we go to do renderings, you're going to get really funny looking materials because the units that are in the materials are again based on inches. So we're assuming everything's in inches, and you'll have to make adjustments if you choose to model in some other set of units. So I'm going to confirm right now that my drawing file is in units. Down at the very bottom, you'll see it'll say C-plane, and then an X, a Y, and a Z coordinate, and then it'll say inches. It's kind of right behind my head. It's right here. You want to make sure that that does say inches, not millimeters. Sometimes the default Rhino file will open in millimeters. So we want to make sure that's set for inches. If yours is not, you can convert to millimeters using the tools. If we go to tools and then options, we can then go to units, and we can change our model units from inches or from whatever to inches. So once again, that is in the tools, options, units. It's under document properties here. And we're going to make sure our model units are set to inches. If you switch from another unit to inches, it'll ask you, do you want to scale? Yes, you want to scale. OK, so I've already set that. The other, just say run free mill. Yeah. All right. So for what we're doing today, we're going to work not in perspective view. We're going to be working just flat as if everything's perfectly on the ground. So instead of working in perspective, I'm going to double click on perspective, or if you have 4 views showing, that's fine. I'm going to double click on the top view like that. And I don't even see my grid. Well, I don't see my grid yet. We'll get there once I start drawing. And we're going to start by using our drawings using the coordinate system. And I talked about this in the AutoCAD section of 135, but I'm going to refresh it here. And that is that this program is fundamentally a math or a vector-based program. So everything has an actual coordinate. The only difference between AutoCAD and Rhino is that Rhino assumes that there's a third coordinate all the time. In AutoCAD, most of what you do is 2D. It's always going to be flat. The third coordinate is always Z. Rhino actually lets you change that third coordinate, and we can work with it. For today's purposes, we're going to assume that everything's at 0 because it's all on the ground. And we're going to go ahead and draw, and we're going to use that coordinate system. This is way back to like algebra, basic algebra, where we drew and plotted points on a graph. We're going to do the same thing today. And I'm going to start with the Polyline tool, which is the tool directly below where the arrow is on the left here. I could also type Polyline or start typing P-O, and it'll show up for Polyline. And now I'm going to start all of this drawing at point 0, 0. And the reason that I'm picking that origin is it gives me a place to start. So I'll actually type in 0, 0 into my command line there. And I'll go ahead and hit enter. Now for me, I was zoomed way out in the wrong spot. There it is. There's my grid. And it starts right there. The important thing here is even if I thought, oh, you know, I'm really good, and I'll just move my mouse right over that point, yeah, I can pick that origin point. As soon as I try to zoom in, you'll see that, well, wait, it's not on the origin anymore. So now I'm zoomed in, and I say, oh, yeah, no, I could definitely hit that origin this time, right? Well, you zoom in a little bit more, and guess what? It's not at the origin. So that's where that coordinate actually matters.
Close it and open it a couple of times.
Hold on one second. There you go. You're good. OK, so I'm going to start with that polyline at point 0, 0. So I'll go ahead and type in 0, 0, and then hit enter. And that starts my polyline. Now you'll see on my drawing, I'm locked into either going in one of the 4 quadrants and it's straight. That's because I have this thing called ortho turned on down here at the bottom, the very bottom of my page. If I didn't have ortho, I could pick any direction or any angle. So to make my life easy, I'll go ahead and keep ortho turned on. And it's showing me just those 4 directions. This works great if you're obviously drawing at right angles to each other. There will be times where you'll want to turn it off. So next, I know that I want a line that is 24 feet long that's going along the y-axis. And so the y-axis is this green axis that's going up here. And I want a line that's 24 feet long along that axis. So I know that my first coordinate was 0, 0. So my next coordinate going straight up this axis, if I want it to be 24 feet long, would be 0, because I'm not going anything in the x direction. I'm staying right at 0, comma, my y direction, I'm going positive by 24 feet. So I'll go ahead and type 24 followed by the apostrophe for feet. And I'll go ahead and hit enter. And that then gives me a line at 24 feet in the positive y direction. If I were to continue, and I wanted a line that went over 12 feet from that 24-foot up line, and don't worry, I'm going to repeat this as we go. If I wanted a line that was 12 feet over here, I could do the same thing by typing in this absolute coordinate. So it's relative to point 0, 0. My next point here would be 12 feet, because it's over 12 feet in the x direction, comma, 24 feet, because it would be up 24 feet in the y direction. So remember, it's relative to point 0, 0. That's why it's called an absolute coordinate. So there it is. I hit enter, and I get that next point in the line. So that's fine, but if I had a really complicated drawing and I didn't know the actual absolute coordinate of where this point was, it can be a little bit challenging to figure out where that point is, or if I didn't start at the origin. So instead, I can use something called a relative coordinate. And what a relative coordinate means is instead of going from point 0, 0 and picking a coordinate, a point, we're going from the last point that we clicked. So in this case, the last point that I clicked was right here. So if I wanted to go down by 6 feet, I could use a relative coordinate to say from this point that I just clicked, I want to go down 6. So I would say at, it's 0 in the x direction, comma, negative 6 feet, because I'm going down 6 feet. So it'd be at, the at sign means relative to the last point that I clicked, go 0, comma, negative 6 feet. And I'll go ahead and hit enter. And that gives me that point. So I could continue. If I wanted a line to go over 12 feet from this point, I could use the at sign. And I could say this time I want it to be 12 feet, because it's going to the right or in the positive direction of x, 12 feet, comma, 0. And I'll go ahead and hit enter. So this point over here has an absolute coordinate. It happens to be 24 feet, comma, 18 feet. But that takes a lot of math to figure out where that point is. It's a lot easier to say at 12 feet, comma, 0 feet. So there's the advantage of a relative coordinate. So I could continue on. I want to go down 12 feet, so this would be at 0, negative 12 feet. I can hit enter. There it is. I want to go back over this direction, and I could say at negative 12 feet, because it's negative x, 0. Enter. Now I could switch back and use an absolute coordinate here. The absolute coordinate of this would be just 12 feet, 0, no at sign, because it's relative to 0, 0. I could hit enter. And then I could finish by typing 0, 0, or I could close my polyline by typing C for close, or clicking the close button. Just means it closes it. So C, enter, closes it. Doesn't matter whether I type 0, 0, or I type C to close it, or I click on the endpoint of my drawing. So I've just created this shape. Let me turn off the gumball for a second. We don't need that right now. I've just created this shape. And like I said, I'm going to do it again. If I didn't start at point 0, 0, it would be a lot harder to come up with these absolute coordinates. So if I started way out here, for example, not at point 0, 0, the relative coordinates would be more important. So I could say maybe at 0, 24 feet, at 12 feet, 0, at at 0, negative 6 feet. You guys get the idea. This is still an awful lot of math to keep track of, the coordinates and which way am I going and whatever. So Rhino actually has a better way, and that is distance and direction. And this is what most of you will do most of the time. There's a few points where these relative coordinates are really valuable, and there'll be an exercise in 2 or 3 class days, where you'll see where this is really valuable and why you'll want to be able to do it, because it makes sense at that point. But for right now, most of what you'll need is distance and direction. So what I'll do here to continue this, and I'll repeat this one more time, is essentially all I'm going to do is type the distance. So the first thing I'll do is type 12 feet. And it's going to ask me, wait, which direction? So remember, distance followed by direction. So I want it to go this direction by 12 feet. Now I want it to go down by 12 feet. Yep. Now I want to go back by 12 feet. Now I want to go down by 6 feet. And then I want to close for C. So it ends up being pretty fast once you do distance and direction. So one more time with distance and direction. We wanted to go up by 24 feet in this direction. Then we want to go over by 12 feet in that direction. We want to go down by 6 feet in that direction. We want to go over by 12 feet. And remember, every one of these is followed by an apostrophe because it's feet. I'm telling it in feet. In that direction, 12 feet down, right? The alternative would be, if I wanted it to go 12 feet over, it would be in inches. So it would be 144 inches. I mean, that's relatively easy math. So I could just type 144, and it's going to assume that it's in inches because that's my default unit. So that's another option. Sorry, I had some control points. So let me continue on. 12 feet in that direction, 12 feet in that direction, 6 feet. Oops. Sorry. I have some snap points that are set. We'll talk about those in just a second, but it's making my life difficult right now. There we go. And then I can type C for close, and I get this shape, which is the shape I've been drawing over and over again. So that gets us through part 1, which is the basic coordinate system. And it's important that you spend some time and really think about what are these coordinates and how am I getting to these specific coordinates, because there will come a point in your modeling where you'll need these. And you'll need to be able to quickly throw in a relative coordinate, for example. So now I'm going to move back to that first one that I drew. These other ones are extras, so I'll go ahead and select them and press the delete key. By the way, in terms of selections, much like AutoCAD, selecting from the left to the right will only select objects that are completely contained within the selection. So in this case, that object is completely contained. It will select it. If the object wasn't completely contained, it won't select it. Selecting from the right to the left, however, means anything this anything this selection touches will be included. So for example, it's completely containing that object, but it's touching this lower object. If I were to let go now, it will select both. The opposite, completely containing the top object, not the bottom object, would only select the top. So getting used to one selection versus the other is an important tool to have in Rhino. It's exactly the same as AutoCAD. Okay, so if you've worked in AutoCAD, that makes sense to you. And it doesn't matter. I was picking from the top. You could pick from the bottom. The same rules apply. It's just from right to left versus from left to right. So I'm going to go ahead and get rid of those. And I'll just press the delete key on the keyboard to get rid of it. And I'm going to zoom in on this particular object. I'm zooming by using the scroll wheel in and out. Alternatively, I could press Z on the keyboard to get my zoom command, in which case I could choose a variety of different selections. The one that I like a lot in Rhino that I will emphasize over and over again is once you have an object selected, type Z and then S for selected, and it will zoom that object to fit the screen. It's really useful, especially when we get into 3D objects, to recenter your view around a new object. And I'll explain that as we go forward, but I'm at least pointing it out right now. If you just want to use the scroll wheel, nothing wrong with that. Okay, so next up, we're going to use something called the offset command, or the offset curve command, to create another version of this line that is 6 inches to the inside of this existing line. And I'm using round numbers here. This is not a technical drawing class. It's not 244. We're not concerned with how thick a wall actually is, because generally it's not 6 inches. But we're using generic terms, and that's fine for what we're doing in this class. So to initiate the offset command, I can type offset. That's one way of doing it. I could go up to curve and then offset, offset curve. Either way will get you to the same place. Okay, so again, it's just whatever feels natural. And I'm going to flip back and forth so you can see it. Now, when it says select curve to offset, that's great. It would be which curve do you want to offset. But there's also a bunch of other information here. So let's go through that. First thing is distance. Well, this is how far do you want it to offset. It's currently set to 1. That 1 is in inches, so it's 1 inch. So if I wanted to change that, I could click on distance, or I could type D because it's the underlined letter. So I'll go ahead and click on distance, and my new distance should be 6. I can just type in 6 because the default units are in inches, or I could actually put the quotation mark for inches. Either way, it doesn't matter. I'll hit enter. Now you see my distance is set for 6. Do I want my corner to be sharp? Yes, I do. Through point we're not going to worry about. Tolerance we're not going to worry about. Both sides we're going to get to in a second. Do I want to offset to both sides or just one side? For right now it'll be one side. In-C plane is set to yes. We'll talk about what that means later on when we get to 3D stuff. And a cap is set to none. So the rest of the options don't really matter. The only one for today that matters is distance. So my distance is set to 6. And my command line is asking me still to select a curve to offset. So there's my curve. And now you'll see a little line that sticks out from my object. That represents my 6 inches. And I need to choose which side to offset. So I want to offset to the inside. So I make sure my cursor is set to the inside of my square, or of my shape here. And when I click, it creates that second wall for me. Pretty easy. So once again, let me delete it. I'll type offset this time instead of going to curve, offset, offset curve. Either one gets us there. My distance is set to 6. If I wanted to change it, I could click on it and then type in a new value. You could also specify a value on screen, whatever that is, 45.07, whatever. That's not what I want, but you get the idea. We go back to 6. There it is. Select curve to offset. There's my curve. We want it going to the inside. There it is, going to the inside. Now I have my set of curves. So that gets us through offset. So then, if you flip the page over, you see that I have kind of a generic floor plan laid out for you. Okay, again, very generic. If you feel comfortable with this, start adding stuff to it, modify it. It doesn't have to look exactly like this floor plan. For those of you that are just barely learning and kind of working through it, no harm in just doing exactly what's here. I have no expectations that you will do dimensions. Those are for your reference, not because you need to actually do them on your drawing. Okay? So ignore the dimensions. They're just for your reference. So let me continue on. And I'm going to do that using some of these measurements as a guide. So the first thing that I need to do is if I'm going to create a door opening, for example, that door is right in the center of this wall. So when I create that, I can use my midpoint snap, which is already set down here. Remember, we turned on the persistent OSNAP dialog. If it's not there, go to Tools, Object Snap, and make sure persistent OSNAP dialog is checked. And I'm going to turn on end and also mid. So the mid will allow me with the polyline to snap right to the center of this wall. So there it is, right in the middle of this wall, set to mid. And you see that when I have my object snaps on, I get a little white square that says mid in it. So I know what snap I'm using right now. So this is right in the middle of this wall. I'll click. I'll come down here. And now you see that my snap has two snaps, perp and mid. So I happen to have perpendicular snap on, so my line will always be perpendicular to the line it's connecting to. But I also have midpoint, and this is the midpoint of that line. So both snaps are being used. Nothing wrong with that. I'll go ahead and click there. And because this is a polyline, I could keep drawing with more shapes. I only need that one line segment, so I'm done. I'll go ahead and press Enter on the keyboard, which gives me that one little line segment. Now I need to actually set up for the door. That's just the middle of the door. I need to know where the outside walls are. So it's a 3-foot door. So half of 3 feet would be 18 inches, or 1'6". And I need to go ahead and do that offset command again. So curve, offset, offset, curve. My distance this time is going to be in inches, so it would be 18 inches. There it is. Now, the cool thing is we can make Rhino do some math. So if you know that, for example, the distance is 3 feet, I could do 3 feet divided by 2. No, it didn't do it for me. I could do 1'6" and do the math myself. So 1 foot followed by the 6 inches. And it would set to 18. So there's different ways of putting it in. If I had 36, I think it'll do 36 divided by 2. Yeah. So if I knew it was 36 inches, I could do divided by 2, and it would do the math for me if I didn't want to do it. So it can do a lot. It didn't obviously do the 3 feet divided by 2. Oh well. So in any case, I want 18 inches because it's half of 3 feet. And this time, instead of offsetting one to each side, I'm going to choose both sides and have both sides set to on, which it is now. And now when I select the curve to offset, it's going to show me on both sides. I can't pick a side anymore because it's going both directions at once. So I'll go ahead and click, and it gives me this line here and that line there. So I have the pieces that are necessary for the outsides of the door. Now I need to get rid of these insides of the door. They need to go away. So I can use the trim command to do that. Trim is available right here under trim. I could also type trim, or I could go to the edit menu and choose trim. So I've got 3 ways of getting to the trim command. When I select trim, it's asking me first for the cutting objects. So what are the 2 cutting objects? This is going to do some cutting, and this is going to do some cutting. So I press both of those. I'll press Enter when I'm done. Then it says Select Object Trim. I want to get rid of this piece, and I want to get rid of that piece. Now I can come over here and I can try to trim this object in the middle, but it doesn't actually touch this or this, so I can't get rid of it. So what I need to do instead is press Enter to finish, and then just select it and delete it. And it goes away. So now I have that opening created in the middle of this wall. So let me back up, and I'm going to do it one more time. I'll use a polyline, snapping to the midpoint there and right there. I'll hit Enter to finish the polyline. I'll go up to offset, so curve, offset, offset, curve. It's going to be both sides. My distance is already set to 18. I'll select my curve, There's my 2 lines. Then I'll use the trim command. I can type trim, or go to edit trim, or pick the trim tool. I'm going to select my cutting objects, which would be this one and that one. I'll go ahead and press enter and select object to trim there and there. I can, by the way, instead of clicking on the individual objects, I can make a selection through those 2 objects and do them both at the same time. Just a little bit of a time saver. I'll hit enter to finish. I'll then select this little line in the center, and I'll press delete one more time. So now I have that opening established. This line is separate from this line, which is separate from this line. I'd like them to all be one line. That will help us when we do our 3D work with this file later on. So I will select all of these, going from right to left. And I'm going to go up to the edit command and then join. I could press Control J. I could type join. There's lots of ways of doing it. And when I do that, these will then all be part of one continuous closed polyline. It's important to do this join when we do the extrusion later on in 3D. So I'll come back and I'll remind you of this as we go forward. So I have my door opening. That's great. It's time to actually draw the door itself. I'll do that using a rectangle. We used the rectangle last class. Same thing here. We'll pick the rectangle. First corner of rectangle would be right here. Now here's an opportunity for using those coordinates. It's a lot easier. I can't just pick a distance and a width. I have to actually do the coordinates. So in this case, I want to go at, so relative to where I started, I want to go negative 1.75 inches, which is 1 3/4 inches. That's an exterior door thickness. You can use round numbers. I'm not going to double check. And I know that my door is 3 feet long. So I said at negative 1.75 inches, go negative in the x direction by negative 3 feet, going negative in the y direction. And when I hit enter, whoops, at negative 1.75 inches, comma, negative 3 feet, enter. There we go. I must have had an extra character in it.
No, you didn't have a comma.
Okay. Anyway, so now I have that little door established. So there's a perfect opportunity to use your relative coordinates. So I have the door, I have the opening. Last thing I need is the swing, so the arc for the swing. So we have an arc tool. As we come down from the Polyline tool, there it is, arc. Pay attention to which arc tool, though. This is an arc center, start, and angle. That one's a little hard to use. Instead, use this one, which is the arc, start, end, and direction. So it's the third one over. If I click that, start of arc, right there. End of arc, right there. Direction. Is it going this way or is it going this way? Really easy. It's going this way. There it is. I have my door swing. So now I have the door swing. That's good. It's time to draw one of the windows. So let me draw in one of these windows. So in this part, I'm going to show you what smart tracking is in Rhino. It's a little different than AutoCAD's tracking system, but it's really, really useful in Rhino to use it. So I need to draw this window, and I know that this window is 1'6" from this corner. And so what a lot of people do by default is they say, oh, okay, let me get a polyline. I'll start at this corner, and I'll go 18 inches. There it is, and I'll draw down, and there it is. Perfect. I've got my line. The problem with that is, yeah, you have your line here, but you also have a line there that overlaps with this line. So you have 2 lines on top of each other. That's not good when we do our extrusions. So we want to be clean. So instead of doing that, we're going to pick the line tool, the Polyline tool, the same way, and we're going to move our mouse over that corner. And as I move over the corner, we get end. But see, I also get a little white dot that stays on the end there. Okay, I haven't clicked at all. I'll then move my mouse in this direction, and now the white dot turns blue, and I get a white line that's running perpendicular. Once I have that white line, I can actually type a value. So I'll type 18 inches, and it's going to move 18 inches positive on that white line from the blue dot. So I'll type 18 inches, enter, and my line now starts right there. I didn't actually draw a line. It's just offsetting from that point, and I can draw perpendicular. And so the end result is a single line that's 18 inches from that corner. I'm going to do it again for the other side. So I'll start with my line. I'll hover my mouse, again not clicking on that corner. I get the white dot. I move to the left this time, and I'm going to type in the value. It was 1 foot from the door, so I'll type 1 foot, enter. There it is. It's 1 foot from that little blue dot, and I can draw that part of the line. So there it is, just a single line and just a single line. No other lines. Okay, that's what we're after. So now I can go through and I can draw the rest of the window. I can go from here to here. Maybe I want to offset to give myself some thickness to the glass. So I'll offset, for example, my distance. Oh, I don't know. Let's do 5/16. There. I really should have done both sides. There it is. Get rid of that original one. Whatever. Do you have to do the double lines? No. I'm just showing you that you can do it. It's the same tools, same offset that we've been doing. I did 5/16, so that means the thickness would be 5/8 of the glass. Whatever. Again, measurements don't matter. It's about the act of learning more than anything else. So now I need to draw the window on this side. So there's very efficient ways of doing this, but in the interest of practice, I'm going to draw it again. So I would start with the Polyline tool. I'll move to this corner. I'll hover over that corner. I get a white dot. I move to the left to start that tracking line, and I'll type 18 inches because it's 18 inches away from that corner. Then I'll draw my line down, snap to perpendicular, and I get this line. Perfect. Same thing. Hover over this point, move to the right, 1 foot, straight down, snap to perpendicular. There it is. Now I have this line and this line. Another line going across to indicate the glass. There it is. And I could just leave it like that, or I could offset it to create some glass thickness. Both sides. There it is. And then we get rid of that original. The alternative to drawing it all again would be to select this window. Remember, I'm selecting from left to right to contain the complete object. There it is. Not from right to left where it selects everything. Left to right. There it is. And I could mirror. This is under Transform, Mirror, or I could type Mirror. And it says Start of Mirror Plane. So in this case, it's just a line. But if it was in 3D, it would be a plane. And essentially, if I snap to the middle of the bottom here, because that's the middle of this wall, I could get the second version of this window by mirroring it, because it's a mirror on the other side. That's just another way of doing it. There's no harm in drawing it again. So let's say, as we keep going, that I want this window right here to be down at the bottom. I could select this window, and I could use that mirror command one more time. So Transform, Mirror. I'm going to snap to the middle right there, and I can put that window down at the bottom. Okay, so let's make life even cooler. Let's say I want this window on this wall right here. I could take that, and instead of mirroring across a straight line, I could mirror across a 45-degree line. So I could go mirror one more time, and I could mirror across this corner from there to there, and I could get the other window. So those are the kinds of things that speed up your work process once you start to understand how you can use the tools to be most effective. I'm not expecting you guys to, one, know that you can do that, or two, do it. I'm just showing you that it exists. Okay, we'll come to efficiency in Rhino a little bit later on. So now I have this window down here. Actually, I should have left it there for now. I could, of course, draw those lines using the same smart tracking technique that we did with the rest of them. I want one more version of this window next to this window. Looks like they're about 6 inches apart. So I could take these two lines right there. And this time I'm going to do a transform copy. Not an edit copy, that's different. We're going to transform copy, or you could just type copy. And it's asking me for a point to move from. I could move from this point, and I could say I want to go over 2'6", because the window's 2 feet, and I've added 6 inches, and that gives me my next point. Or, oops, I could move and use smart tracking from this point to go back 6 inches and then copy it to that endpoint. Either way, oops, I was meant to do copy, sorry. 6 inches, like that. Either way, it works. So there are, of course, lots more commands that you can play around with. Extend, fillet, chamfer, mirror, rotate. We'll cover all of these a little bit later on. If you feel comfortable, you can, of course, keep going, embellish this a little bit more. But the basic commands that we're trying to master today and to feel comfortable with today are the coordinate system, so basic polyline drawing with the coordinate system. The offset command, making sure you can offset lines to one side or the other. The trim command, to be able to get rid of line segments. The join command to join line segments together. And I'd like you to be able to do smart tracking, where you can draw a line that's offset from a point. Okay? When you're all done with this, I want you to export your drawing. And instead of printing it, I'm actually going to have you do something slightly different. You're going to go to the little triangle next to where it says top, and you're going to go to Capture to File. This will create a screen capture of what you're seeing on your screen. That's what you will post today. And if I lost you there, don't worry. I'll help you when you get to that point and you have your drawing ready to post. Okay? But for those of you that feel really comfortable with it, you're going to go to that triangle. You're going to go to Capture to File. It'll ask you where you want to save your file. You'll probably end up saving it in your folder for today and calling it whatever. This is spring of 2018. And you'll go ahead and save it. Now, one other thing, that saves the JPEG. You want to make sure that you actually save your Rhino file too. So go to File, Save, and save that Rhino file to your computer. There it is. And this is, for me, is the spring of 2018. Just making sure I have the right version here. And then you'll click Save. We will work with this same file next class. So you want to make sure you save it. Make sure you save it to your OneDrive folder, hopefully the one that you're already syncing, so that it will sync for you. And that then will be the file that we'll start with next class. So remember, I said everything builds on itself in the beginning. So it's important that you actually save that file, otherwise you'll have to draw it over again. Okay? Are there any questions before you guys get started? No? Okay, I'll float around and I'll help you guys if you get stuck.